For this problem, we are going to determine the free energy change under standard conditions for this hypothetical reaction. Then oxaloacetate oxidizes lactate into pyruvate and becomes reduced itself into malate. So we know that this is an oxidation reduction reaction, right? Because here we have oxidation state for this carbon of lactate is 0, and in its oxidized form it is going to be +2. And the same thing happens with oxaloacetate, with this alpha carbonyl carbon atom of oxaloacetate. So it starts with the oxidation state of +2, and it becomes reduced to the alcohol oxidation state, which is 0 here. So we know that lactate serves as a donor of 2 electrons for oxaloacetate. And we know that for an oxidation reduction reaction, we can actually determine the change in the reduction potential. And once we determine that, we can use this value to calculate free energy change for the oxidation reduction reaction using the equation as follows. Delta G equals to minus N F delta E. So N is the number of electrons that are being transferred, and in our case, we have 2 electrons, right? And again, it's just the number, so we don't include the charge, right? Because we know that electrons are negatively charged, but we don't include that. It's not a charge, it's just the number of electrons. F is our Faraday constant, and the last value we are going to calculate now. So for an oxidation reduction reaction, the change in the reduction potential can be determined as the reduction potential for the oxidizing agent, right? Such as oxaloacetate now, minus the reduction potential for the oxidized form of the compound that is being oxidized, right? So here we are talking about pyruvate, oxaloacetate and pyruvate. And we can take the tabulated values for that. So for oxaloacetate, the reduction potential for its reduction to malate equals to minus 0.166 volts. And then minus the reduction potential for pyruvate, which is going to be reduced into lactate, is minus 0.185 volts. And so we can do the math, and it's going to be plus 0.019 volts. So we can already determine that this reaction is spontaneous because the reduction potential difference is positive, and as a result, the free energy change for this reaction will be negative. So now let's plug our numbers in here. So don't forget to transfer the minus here because that's a common mistake. Minus 2 electrons are transferred. Right? Let me go back to the pink color because it writes better. So minus 2 multiplied by the Faraday constant, which is 96,485, and by the value that we calculated. And I'll keep this plus just to emphasize that sometimes it's important to double check the sign because sometimes you forget that it's negative and forget to put it here. But in this case, it's positive, right? So as a result, our free energy change will be equal to minus, and now I'm going to calculate the value, 3,666 joules per mole. Or you can say minus 3.7 kilojoule per mole.